Increasing the electrical load carried on a transmission line increases the line's temperature, and too great a load will cause the line to exceed its maximum operating temperature. The line's temperature is also affected by wind speed and direction. Strong winds cool the line more than light winds, and wind blowing across a line cools it more than does wind blowing parallel to it.
All right, so what are all the things that can impact the line's temperature?
Wind and the direction. So if it's going parallel versus in the same direction, and I guess like the load.
Yes. Okay, awesome. So I don't know when I went into this when I saw that it was most strongly supported. I remember thinking, okay, I know that these two things like I don't know how much like the load can compare to wind speed and direction. Like can those like um cool it down enough to overcome a certain load? And we don't have that comparison at all, and I kind of predicted that they were going to be tricky answers about that being wrong. All right, but go ahead and start with A, Malika.
All right, A. Electrical utility companies typically increase the electrical load on their transmission lines on days on which the wind has a strong cooling effect. So I went with this answer.
Okay. And why is it wrong?
So like that's where I was confused. I mean, I guess I have to read through the other answers, but I felt like that was pretty supported.
Okay, so do we know what the electrical utility companies do when there are strong winds?
I mean, I guess not. We just know that the strong winds cool.
Yes, and so this goes into what I kind of mentioned earlier. We don't know how much like increasing the load or the electrical load, how much the wind can actually counter interact.
Okay.
Do you see that? And we don't know what the like this one in common sense world. I think A makes sense, and it's super tempting. We can make that assumption so easily, but at the end of the day, we have no idea. Like maybe the electrical utility companies are afraid of getting sued, and they're like, we can't go above this amount no matter what, even if the winds are going to cool it down. Maybe
Okay.
it's not worth the risk. All right, go ahead and do B, Malika.
B, transmission lines that run parallel to the prevailing winds can generally carry greater electrical loads than otherwise identical lines at a right angle to the prevailing wind. So I crossed that out right away because that's like opposite of what the last sentence was saying.
All right. What about C?
So that was the other one I was stuck on. The electrical load that a transmission line can carry without reaching its maximum operating temperature increases when the wind speed increases.
So what happens when the wind speed increases?
The line cools down.
And so when the line cools down, couldn't our load go up?
Yeah.
So yeah. So the big difference between A and C is just A is saying like the load could, like the optimal load like could increase because of it's all based on temperature. Where A, we have to go with that extra assumption and say what the electrical utility company actually does. Where with C, we don't have to make that assumption.
Okay. Yeah, I see that.
Awesome. Okay, what about D?
Air temperature has less effect on the temperature of transmission line than wind speed does. We don't know that.
Okay.
And then E, the maximum operating temperature of a transmission line is greater on windy days than on calm days.
What do you think about that one? I thought this was a tricky answer too.
Yeah, I honestly I don't know if I got to that one now that I think about it. I would still go with C, I think.
Maximum operating temperature of the line is greater on windy days than on calm days.
I don't get what that's saying. Like I'm trying to be like, okay, the maximum operating temperature exceeds when the load increases.
Because I think like for E, like I was also confused about E, but I think what E's saying is that like the maximum amount will be like higher on a windy day as opposed to like a normal day. But we don't know like if the maximum amount can either go up or down. Like, what if it's a set
Oh,
amount?
yeah, that maximum allowable temperature. Yeah.
Yeah. Like, what if it's like a set amount? Like, you know.
Oh, okay. So like the company, it kind of is like for A, it's like, what do we have a set amount no matter what?
Yeah.
I also thought like it also doesn't tell you that like which way the wind is blowing.
Yeah.
What if the windy days are running parallel to the lines? Then it wouldn't increase the temperature that the line could go.
Well, but it could cool it more. I think, but it's comparing windy to calm, and I think windy,
I think
even
in general,
even windy that's parallel was still cooler than calm.
True. Okay.
The maximum operating temperature too great a load will cause the line to exceed. Oh, okay. So a too load of a line will cause it to exceed its maximum operating temperature, and the maximum operating temperature might just be set.
yeah.
I thought E was the hardest wrong answer.
I think I might have just crossed out E because I didn't understand what it was saying.